follows right along with, we're still talking about functions. The difference today is that we're looking at inverse relations and functions. So we're going to look at what is an inverse relation? How do we know if it's a function? How do we know in general if relations are functions? And we're going to look at the graphs of these. And a lot of it is just going to be finding the inverses. Okay? So a little bit of vocabulary to get us started. A relation is a set of any ordered pairs, x comma y, where x is the independent variable and y is the dependent variable. So we have just a set of ordered pairs in general. Don't necessarily know if it's a function. We just call it a relation. X is always the independent variable. That's something like, for instance, time. Time is independent. It doesn't rely on anything else. Whereas y is your dependent variable. It depends on whatever x is doing. Okay? Function. A function is a relation in which each element of the domain corresponds with exactly one element in the range. We've talked about functions before. I don't remember if we've talked about them earlier this year or not, but we've definitely talked about them in previous classes. So we'll talk about a couple of different ways you can determine function. One is each element of the domain corresponds with exactly one element of the range. Or the shortcut you've probably gone to is just the domain, the values in the domain cannot repeat. We'll also talk about a certain test. Remember the vertical line test? We'll review the vertical line test and how that works. Now, inverse. An inverse relation is formed when the roles of the independent and dependent variables are reversed. So that's taking your x values and your y values and switching them. Okay? And then if you know something is an inverse function, it can be, you can use f inverse of x, so f to negative 1 of x as your notation to show that it is an inverse function. Okay? So let's look at A. We'll start easy. Identify the inverse relation, and then is it a function? So let's talk about what's the inverse. The given relation is negative 2, 1, negative 1, 4, 0, 3, and 1, 1. Thoughts on what the inverse is? This one's easy. What did it say to do up above to find your inverse? Inverse is formed when the roles of the independent and dependent variables are reversed. So negative 2, 1 in the original relation becomes 1, negative 2 in the inverse. Just taking the x and the y and switching them. So what else? Negative 1, 4 becomes 4, negative 1. 0, 3 becomes 3, 0. And 1, 1 becomes 1, 1. Okay? So that is your inverse relation. Taking your x and y's and switching them. In homework, I don't know if they have you fill in any tables or if it's more of an ordered pair thing, where if they give you the ordered pair 2, 3, you give the ordered pair back of 3, 2. Now, while we're here, I also want to talk about functions. Let's go to this original relation. I know that's not just what the question asked me, but these original 4 ordered pairs, is this a function? If it's a function, each element of the domain corresponds with exactly one element of the range. Does negative 2 go with 1 and only 1? Yeah. Does negative 1 go with 4 and only 4? 0 with 3? And 1 with 1. Okay? In other words, each of these x values is used how often? Just once, right? None of my x values repeat. So is it a function? Yes, this is a function. Okay. It doesn't matter about the range repeating. The idea is that each x value pairs with a different y value, or pairs with just one y value. That's what I want to say. Now, inverse. Is the inverse a function? So the catch on this one pairs with -2, and one pairs with 1. So each element of the domain corresponds with exactly one element in the range? No, that 1 repeats. It pairs with 2 different range values, so this one is not a function. Okay, so your inverse is not a function. The original was a function. Okay, B. Another table. Keeping it easy right now. Not even sure how I did that. Okay, thoughts on your inverse relation? -1, 9 becomes 9, -1. 0, 7 becomes 7, 0. What else do I have? 5, 1, 3, 2, 1, 3, -1, 4. This is your inverse relation. Now, I want to ask the function questions again. Is my original relation a function? Each x value is used just once, right? So each x value pairs with exactly one y value. -1 with 9, 0, 7, 1 to 5, 2 to 3, 3 to 1, 4 to -1. So my original relation, yes, it is a function. What about the inverse? Each x value used once? 9, 7, 5, 3, 1, -1. They're each used once. So what about the inverse? It is also a function. Okay. So a little bit of basics there. Switch x and y to find an inverse. It's a function if each x value is used once. Pairs with one element in the range. Okay. The bottom part of this page, we're going to spend some time on, and we're going to start looking at how to find inverses using an equation and kind of looking at how to use the graph. Just like when we were finding the inverse up here, we were taking our x value and our y values and switching them, right? In an equation situation, in order to find the inverse of an equation, you're going to switch your x and y. You're going to switch the roles of x and y. The key then will be solving for y, so we can put it in a typical equation form. And something that I'm going to demonstrate here as well is that the graph of a function's inverse will always be reflections across the line y equals x. So that's another thing. If you're given an original relation and an inverse, we can tell if they are truly inverses if they reflect across the line y equals x. Now, line y equals x, does that make sense if I draw that? It is that perfect diagonal line that goes through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, right? If it's y equals x, it goes through that perfect diagonal line. So that will be our line of reflection. It's not your traditional horizontal or vertical reflection line. It's a diagonal reflection line. Okay? So that's the information we're going to use down below. Down below, we're given an equation, a function. Write an equation to find the inverse of f. Then we're going to look at graphing f and the inverse of f And we're also going to talk about whether the inverse is a function. Okay? Now, our original function is f of x equals x squared. Excuse me. In order to find an inverse, we have to be able to switch x and y. Where's y in my equation? Do we know? Yeah. Remember, guys, when you see f of x, g of x, h of x, any of those function notations, those are replacements for y. So realize when you see f of x equals x squared, that's the same thing as saying y equals x squared. So now, in order to find my inverse, take x and y and switch. So instead of y equals, I'm going to say x equals. Instead of y squared, I'm going to say, instead of x squared, I'm going to say y squared. My brain was thinking ahead there. So right there, I switched the locations of my x and y. So now I have the equation x equals y squared, and that represents my inverse. Now, traditional rule of thumb, solve it for y. So I'm going to go ahead and reverse this. If this is y squared equals x, how do I solve that for y? Yeah. If I want y squared to become y, we're going to square root it. If I square root the left, we square root the right. What is the square root of y squared? Y. What is the square root of x? And? Yeah, plus or minus the square root of x. Remember, when you are taking that square root in an equation setting, you use plus or minus the square root. So right here, this is my inverse, okay? So y equals plus or minus the square root of x is my inverse. Now I want to graph these. And there's a couple of different ways we can go about graphing them. My recommendation, though, is I'm going to start with graphing y equals x squared. We start with graphing y equals x squared. I would like to think you have some idea what that graph is going to look like. And I say that because I've taught it to you this year. So there's no claims of, oh, we've never learned this before, because I've taught it. And I know you learned it in Algebra 1 too, but y equals x squared. Can you visualize what that graph is going to look like? X squareds are what? Now, what's the graph x squareds? The graph of x squareds. They are parabolas. The U shape, right? Okay. Sounds slightly familiar, right? Yeah. I'm not crazy here. I promise. So you can think x, y values. Do you remember what x, y values we used at the time? Yeah. And if we think, and I'm going to put them down here for a moment for a reason. At the time, we just did 0, 1, 2, didn't we? Because if you put in 0, 0 squared is 0. If I put in 1, 1 squared is 1, and 2 squared is 4. And then what did I tell you to do with those values? Take them and reflect them, right? Now, if you want, you can also think of that as we put -1, -2 it. -1 squared is +1. -2 squared is 4. If you want to go one more, not saying you'd have to, but you could go to 3, right? What would 3 have? 3, 9. And that would also, if you put in -3, it'd be -3, 9. I heard someone throw out 3 there, so I wanted to mention that. Now, let's graph this. As I said, at the time, I would have just had you graph 0, 0, 1, 1, 2, 4. Do you remember graphing those 3 points? And then I would say, oh, reflect them. Negative left 1 up 1 and left 2 up 4. Now, if you went ahead and want to do 3, 9, right 3 up 9. And also that means left 3 up 9. And we have a parabola that looks familiar, I hope. So that is your equation. Y equals x squared. Is that a function? Well, officially, it was provided as f of x equals. So officially, it kind of tells us it's a function. But each x value pairs with one y, yes? When I put in, say, 3, I don't get 2 different numbers when I put in 3. I only get 9. And then, do you remember the vertical line test? I don't know if I've taught vertical line test this year or not. I might have mentioned it. I don't know. But vertical line test, if you draw a vertical line, and it only crosses the graph once at a time, right? Then it passes the vertical line test. So like, and I'm going to erase this, but if I draw a vertical line here, how many times did it touch my graph? Once. If I draw it over here, how many times did it touch my graph? Once. Anywhere I draw it, it's only going to ever touch my graph once. So that's your vertical line test. So is this a function? Yes, this is a function. And I'm trying to get us in the situation where we can acknowledge whether or not something's a function.
Just some info I got from College Board. So since you have a lot of juniors, there it is.
Okay. About SAT, which we were just talking about SAT during passing period. Okay, so that's our original function, yes? Now let's talk about the inverse. And I'm going to come over here with this one. My inverse is y equals plus or minus the square root of x. We have options for graphing this. Thoughts on ways I could graph this? No? That would work.
4, -2.
And why are you saying 4, -2?
Because I just switched up.
I say, I'm assuming you took this and you're reversing it, yes? Is that an option? Yeah. Now, morning class kind of bulked at this, so I don't know if you guys will or not. Technically, in this chapter, I taught you how to graph y equals square root of x. We didn't do the plus or minus, but we've already quizzed over, and it's going to be on the test next week. Y equals square root of x, do you remember graphing those? I know, that morning class was very like, oh no. We did, because at the time, we used what? We used 0, 1, 4, and 9. And why did I use 0, 1, 4, and 9? Perfect squares, right? Now, square root of 0 is 0. Square root of 1 is 1, or technically -1. Well, what does that match up with? 1, 1. It matches up with both of those, right? So a way you could write this is 1, -1. If you don't like it, write it, if you've already written this as just reversing the other ones, that's fine. What about 4? The square root of 4 is 2 or plus or minus 2. That matches up with 2, 4, and -2, 4, doesn't it? 9, the square root of 9 is plus or minus 3. That matches up. So it is also switching them, right? I promise it is. Let's graph this. 0, 0, we got that one. Now realize, what does 1 plus or minus 1 mean? You're going to be graphing 1, 1, and you're going to be graphing 1, -1. Right 1 up 1. This is what we were graphing already in this chapter, right? Right one down one is because of the plus or minus. So 4, 2, we were already graphing that in this chapter. 4, negative 2 is because of the plus or minus. And the other one, 9, 3 is what we are already graphing in this chapter. 9, negative 3 is what we also have. What we've already been graphing is the top half, correct? Because the top half is just y equals the positive square root of x. And that's what we are graphing back in lesson 5.3. I think it was 5.3. Okay? But we also, in this case, because we have the plus or minus on there, have the bottom half. Okay? So multiple different ways. Could you have just flipped your chart? Yes. Okay? I was also trying to bring back the idea of the square root function. So this right here is y equals plus or minus the square root of x. This is our inverse. And I want to know, is it a function? I don't know, I've seen both answers so far, so. If we say no, why not? Okay, so one way is to look at this right here. 1 matches with 1, and 1 matches with negative 1. That plus or minus sign is a huge, like, red flag. When you see a plus or minus sign, it's not going to be a function. What about vertical line test? I'm going to erase this, but if I draw a vertical line, what happens? I just passed through there twice, right? So it fails the vertical line test. So this is the inverse relation, but it is not a function. Okay. Now, one more thing before I move on to the next one. Up right above this, it's on my previous screen. It said all functions and their inverses will reflect across the line y equals x, right? The line y equals x is the line that goes through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, all the way up to 10, 10, and it also goes down here, right? So the idea, I can't fold my bin Q, but you could fold your paper if you wanted to. If I took my graph and I folded it along that diagonal line, guess what these parabolas should do? They should land on top of each other, right? And that's another way. It won't be usually the way we use to tell if a relation and an inverse are truly inverses. But technically that is one way to do it is if I fold this in half, do these parabolas land on each other if I fold it diagonally in half? Okay. Okay. Questions on this one? I know I threw a lot at you. And more than anything, I'm trying to make some good connections here. Okay. Homework is going to be more about finding the inverses. Are they functions? But I'm trying to pull this all together into relationships here. So, okay, let's look at B then. How do I find the inverse? Sorry, labeling that y equals x up there. What do we know about f of x? F of x is it's another name for y. So this equation is actually y equals 2x minus 1. How do I find the inverse? Okay. Instead of y equals, I'm going to start with x equals. Instead of 2x minus 1, 2y minus 1. Solve for y. If it's 2y minus 1, I'm first going to add 1. So then I have x plus 1 equals 2y. How do I solve for y here? Divide by 2. Now, there are a couple of different ways we can divide by 2. One option is I can divide by 2 just like that. And I can say that y equals x plus 1 over 2. Okay? Or the other option is that I could divide both pieces by 2. And if I divide both pieces by 2, I'm going to have x over 2 and 1 over 2. Now, when I say x over 2, keep in mind that that could be 1x over 2, or in other words, 1/2 x plus 1/2. I'm happy with either of those. I actually kind of think if you have a situation like that, the sophist would accept either. Don't quote me on that, but I feel like I tried it on something recently and it accepted it, but maybe I wasn't on sophist. Okay, so those are your options for the inverse. Okay, let's graph these. Okay, y equals 2x minus 1. What is it? What form is that in?
Y equals mx plus b.
Yeah, y equals mx plus b. So this is just a plain old line. Maybe I should have led with this one instead of the parabola. This is just a line, and if it's in y equals mx plus b, where m is our slope of 2, and b is our y-intercept of -1. True? You could graph using that information if you want. Okay, where y-intercept of -1 means we go down 1. What's the slope of 2 tell us to do?
Up 2 right?
Because what phrase do I use for slope? She said up and right, but not disagree. There we go. Okay. A slope of 2 is the fraction 2 over 1, which is rise 2, 1, run 1. We've gone over that this year, right? Maybe we haven't graphed lines recently, but you're supposed to know how to graph lines. So if I do this, rise 2, run 1. Rise 2, run 1. You can do this as many times as you want, yes? You can also reverse it and go down 2, left 1. I'm going to try to connect these dots. Well, not perfect, but it works. If you wanted to, could you have done an XY chart? Sure, you could have done an XY chart, couldn't you? You could have put in 0. 2 times 0 is 0, minus 1 is -1. You could have put in 1. 2 times 1 is 2, minus 1 is 1. We could have put in 2. 2 times 2 is 4, minus 1 is 3. Are those all points I have here? They are. Okay. Now, that's all about our original function. Options on graphing the inverse. Could you just flip points? Most definitely. You can just flip points if you want. And if we flip points, if I use what I have up there, -1, 0, 1, 1, and 3, 2. I don't know why I left that gap. I was thinking I wanted another point there. Maybe I will, I don't remember. But if you plug in points, it'd be easiest to do this over here in this one, because negative 1 plus 1 is 0, divided by 2 is 0. If I plug in 1, 1 plus 1 is 2, right? Divided by 2 is 1. If I plug in 3, 3 plus 1 is 4. 4 divided by 2 is 2. They all work, don't they? So you can go ahead and do that. It's what? Negative 1, 0. So left 1, up or down 0. 1, 1, right 1, up 1. 3, 2. Right 3, up 2. Technically, if you want, you could continue with more dots. Are you noticing a common relationship? There's a slope of, if you look right here, there's a slope of 1/2, isn't there? Rise 1, up 2, rise 1, up 2, rise 1. I was saying rise 1, up 2, wasn't I? Okay, don't do that. Rise 1, run 2. Or reverse it. Down 1, left 2. Okay. So, either way, we got this. Now, a couple of things. Are these functions? Do they pass the vertical line test? Just one at a time, right? So like if I forgot to do it earlier, but if we look at our original blue line, does that pass the vertical line test? Yes. If I look at my inverse red line, does it pass the vertical line test? Yes. Or the fact that x's don't repeat. So these are both functions. And then the other question, or the other thing I was going to have you do is draw in the line y equals x. Hello. I can't. Chloe, you're wanted in the guidance office. I have no idea. You can leave it here if you want. It'll be here if you know. Okay, so these are both functions, right? They both pass the vertical line test. Their x's don't repeat. Does it make sense that they are inverses if you look at the line y equals x? Line y equals x is that perfect diagonal line that goes straight through the middle. Can you see folding that on the green dotted line there? Blue and red would reflect on each other up here. Down here, same thing. Blue and red would reflect on each other. So that is reflection across the line y equals x. Okay. Did I get everything on that one? I think I did. So I will. This is the line y equals x. I think I got everything there. Okay, questions at this point? Okay, where are we at time-wise? About 5 minutes. We can look at least one on the back. That's super quick. I should have said Miss Myers called for you. Mrs. Myers called for you, so. Okay. Let's look at the back. They'll speed us up tomorrow. Because we kind of already know what we're doing on the back. We can get through one of these. Find an equation for the inverse of the function is the inverse of function. How do we find the inverse equation? Flip, right? We're flipping x and y. Now, keep in mind, what is f of x? Okay. That's the same thing as y, right? So really this equation is y equals square root of x minus 2. To find the inverse, we're going to flip. Instead of y equals, x equals. Instead of square root of x minus 2, square root of y minus 2. Now your job is to solve for y. Thoughts on how I work to solve for y on this one? that y is under a square root, right? So since y minus 2 is under a square root, to get rid of a square root, we're going to raise to the power of 2. What we do to one side, we do to the other side. So what is x when you raise it to the power of 2? X squared. Square root of y minus 2 squared. Okay, when you square a square root, you get whatever's under it, so y minus 2. How do I get y by itself? Add 2. If I add 2 on one side, we're adding 2 on the other side. And so I'm going to have x squared plus 2 equals y, or what I prefer to write is y equals x squared plus 2. Now, is the inverse a function? We can think of this two different ways. My preference, if it's a graph we know, can you visualize this graph? What is y equals x squared plus 2? Yeah, x squared. I expect you to know that that's a parabola. The plus 2, we've been doing this all year, plus 2 takes it up 2. Is a parabola moved up 2 going to pass the vertical line test? Yes. Parabolas, normal right side of parabolas are functions. So is this a function? Yes. Okay. It is a function. Now, I will say, I'm not saying you have to, but since I know it's a function, I can actually rewrite it as function notation saying f inverse of x equals x squared plus 2. Solvists, when you have to enter it, they'll already have the beginning part. I don't remember if they use f of inverse of x or if they use y, but you know they'll already have that. Okay? The other way, start plugging in values if you're not sure if it's a function. If I plug in, say 1. 1 squared is 1, plus 2 is 3. Is there any way I can get anything else other than 3 when I plug in the 1? No, that's the only thing I can get, right? If I plug in 2, there's only one answer that's going to pop out. So that also tells me it's a function. I will tell you the big time it's not going to be a function is the plus or minus signs. Okay? Because when you plug in plus or minus, you have two options that pop out. Okay, so that pretty much ends us, doesn't it? So we'll do a few more tomorrow, practice solving, and we'll look at some compositions at the bottom. Make sure if you didn't get 5.0